Alright, so let's go ahead and make sure our blueprints are set up correctly. We're going to want to construct our embedded voice chat audio capture and set that as a variable. We're using our game instance to set a lot of these variables because the game instance is a good place to store variables that move between separate levels. From there, we get capture devices available. Make sure that that is greater than 0. And then we're going to open the capture stream. Number of frames desired, we set it to 480. Run a branch, make sure that is successful and works. Start capturing audio, get capture device info. And then we're going to break that embedded voice chat audio capture device info, and we're going to set our input device ID and our input device name. And again, we're going to save those inside of our game instance. Now here we head over to BP audio device UI. In the event construct, we're going to go ahead and add our mapping with our owning player. Again, we're going to check and make sure our game instance is valid. If not, we're going to set the game instance and then get capture devices available. This is all inside of the UI, so we can make sure we set up our UI correctly. You should download the example project to follow along with this type of stuff. This is inside of our game instance right here, and that's where we're saving all those variables. Get the capture devices available and set the out devices as the input devices. Our target is going to be that voice capture. Then we're going to run a sequence right there to add options for each of the input devices that we have. We'll set the default device. We're going to use this gate to set a base that nothing's there if there is not any devices to loop through to set up as an option. Now here you can see what the UI is going to look like. It's going to, I mean, all the stuff in this tutorial is going to be very basic UI, but that would be you'll see, it'll load on the event construct. Yeah, we'll load all the input devices that are available on your computer. On event destruct, yeah, we'll remove the mapping. And then we'll have this refresh input devices available, and that will run the same as the event construct to get all the input devices that you have, or say you have none. And then down here we have a couple events, pretty basic, where we just either add a mapping context or remove a mapping context. Play a simple animation. And then we'll have a combo box, as you can see, that we'll just update to whatever the active device is on that changed, basically. When someone changes their selection inside of the combo box, we will update that. And then basically running a similar function to what we did before, where we'll get the capture devices available, loop through them, and if it equals the selected one, we'll open the capture stream, start capturing audio, and yeah, get the selected index. But yeah, go ahead, start capturing audio when someone changes to the new device that they've selected. And that's the basic UI system that we have in place.
Okay, let's package a dedicated server build. And then we upload it to the server hosting service we are using, which is GameLift. We will use Linux ARM server because Linux ARM server is the cheapest selection. Okay, let's package it. Okay, it's finished. Let's place the embedded voice chat server related files into our server build. These files contain an install.sh file. It's used to add the embedded voice chat server into a Linux system and enable it. The embedded voice chat server is a stun turn server, which is used to establish peer-to-peer connections. Next, we zip up the files of Linux server build. It's finished. Now let's upload it to the S3 box we created in the first video. Okay, done. Let's create the game of build-up fleet and alias. just the same as the first video in this playlist. The only thing that is different is that we create 5 ECTA port settings here. The first one is 777727781 UDP port for dedicated game server because we have 5 concurrent processes. The next two is 19302 TCP and UDP port. It's used for stun server. It supports both UDP and TCP mode. The next two for turn server. It supports TCP and UDP mode as well. Now, the fleet is active and online. We need to test our stun turn server to make sure it runs well inside the fleet instance. We will use a website which is called Trickle Ice to test the stun and turn server. We will post its link in this video description. You can see how we construct the URL for stun and turn server in the example project. Let's do the same thing in Trickle ICE. We can get the IP address of the fleet instance from a pre-created game session in GameLove console. We have already run a PI client to test the fleet before we record this part, so there is already a game session. Copy the IP address to Trickle ICE. And combine it with the stun turn server port. Add server. And gather candidates. If there is an S or FIX record, it means the stun server is running well.
Okay, and so now here's the final product in game that you can see. We have the input devices to come up. You'll be able to select between that combo box right there. You're able to refresh. Once there, you're able to change your selections, and that's the simple UI device of how it will work.